Today we will discuss the integral for another function, the integral for cosec. How we will find the integral for this type of function. It depends on the type of the power. If we have even power, then usually the integral will be solved by substitution method. And if we have odd power, then the integral, it will be solved by integration by part. As we can see here, it is the same concept and similar to what we discussed in the previous lecture with the integral for sec function. Let's see this example. Find the integral of the following function, integral cosec to the power 8x dx. As we notice here, it is even power. So the integral will be solved by substitution method. What we will do, it is even power, then we withdraw 2, we will get 6. So the integral will become equal integral cosec to the power 6x multiply cosec to the power 2x dx. And we need to put this part in the quadratic exponent. So it will become cosec to the power 2 all to the power 3 multiply cosec square x dx. We have cosec square, then we will use the cosec square formula. Cosec square equal cotan square plus 1, and we will substitute this value in this part. We will get this integral. The integral cotan square plus 1 all to the power 3 multiply cosec square x dx. We can use now the substitution method. We will take this function for our assumption. So it will be u equal cotan x, and after taking the derivative for both sides, we will get du equal minus cosec square x dx. And after multiplying the negative sign with the both sides, we will get minus du equal cosec square x dx. After that, we will put the integral in term of u, and we will get this result. And how we will solve this type of function, we just open the cube expand. After expanded the cube, we will get this result. Now the integral is become easy to find the solution. We just increase 1 to the exponent and divide it to the new exponent. And we will get the result of this integral in term of u. The last step, we will put the integral in term of x. We just substitute the value of u. What is u? u equal cotan x. And it will be the final result of this equation. Let's see another example. Find the integral of the following function. We have integral cosec to the power 3x dx. How we will solve it? As we notice here, we have odd power. So the solution will be by using the integral by part. What we will do, we have odd power 3, we withdraw 1, we get 2. So the integral will become integral cosec x multiply cosec square x dx. And we will use the formula for the integral by part. Let's take our assumption. This one it will be u, and this part it will be dv. u equal cosec x, and this part it will be for dv, then dv equal cosec square x dx. With derivative for this part, we'll get du equal minus cosec x multiply cotan x dx. After making the integration for dv, we'll get minus cotan. Then we will substitute all these value in the formula for the integral by part, and after the simplification, we will get this result, and we will call it equation number 1. Notice here we have remaining integral, so we will try to solve this remaining integral, the integral cotan square x multiply cosec x dx. We have already the quadratic exponent, so we'll use the formula for the cotan square. The integral will become integral cosec square minus 1 multiply cosec x dx. And after open the bracket and distributing the integral to the function by using the integral properties, we will get this value, integral cosec to the power 3x dx minus integral cosec x dx. This integral will keep it as it is minus What is the integral for cosec? It will be ln cosec x minus cotan x, and we will call this equation number 2. Notice here we have integral cosec to the power 3x dx, and also in the question it is required to find the integral for cosec to the power 3x dx. So what we will do, from the equation number 2 we will put it in the equation number 1 to get the final result of this integral. This is from the equation number 1, and this is the remaining integral, which is this part from the equation number 2, and after open the bracket with the negative sign, notice here we have integral cosec to the power 3x dx. So we will transfer this part to the other side, and we will get 2 integral cosec to the power 3x dx with this result. Now the integral is already solved. We just divide the integral with the number 2 in this side and this side, and we will get the final result of this integral. As we notice here, it is simple and easy, and it is same concept and same idea and same principle that we use it when we made the integral for the sec function in the previous lecture. This is for today, and see you next lecture.